In today's math lesson, we're going to complete a table and graph a linear function. The goal for this lesson is to see how an equation, table, and graph correspond. Once you have an equation, you can use it to find the missing values of a table and then plot those points from the table onto a graph and see how the original equation looks in pictorial form. There are a couple of different ways we can go about doing this process. The first one will be by hand. So step one of doing this by hand is just to plug the given table of x values into the equation and then simplify to get your y values. We've done this in a previous lesson, so this should not be new, nor should it be difficult. After filling in the table, you will plot each row, remembering that each row is a coordinate point on the graph. Finally, you will connect the points with a ruler. Don't just leave random points or even instructed points on a graph. You need to tell what's happening with them. They're making a line. So you connect them with your ruler and you run an extended amount of distance beyond the points, both before and after. Now, if your teacher allows you to use the TI Nspire to help you fill in the table, these are the steps that you will need. Starting on a page for a graph, type in the equation that they give you in the problem, and then push enter. After you've graphed the equation, you're going to pull up the table by pushing Control T. So that will give you the table in the calculator of all of the x values for the given equation that you will then use to fill in the table that you have been given in the problem itself. Let's see how this works. Example 1. We are going to complete the given table where f of x is equal to 2x and then graph its function on the given coordinate plane. We're going to work out example 1 by hand, so let's do that together. Our function is 2x, all right, and we need to substitute in for the x value 0, 1, and 2 to find its corresponding y value. Let's do that. So it is 2 times something for every row of the table. 2 times the given x value specifically. So 2 times 0, 2 times 1, 2 times 2. So we are using this exact function to help us fill in what we need in our table. 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4. Now we can fill this in and then go use this information to plot the points on our coordinate plane. Quick hint, from the introduction, we saw that each row of the table is an actual coordinate point. So each row will be one point that we place on the coordinate plane, remembering that the x values always move left and right, while the y values move down or up. Let's go ahead and plot these points. Our first row is 0, 0. So that is here at the origin down in the corner, point 0, 0. Great. Our second row is the point 1, 2. So our x value is 1, our y value is 2, and there is our second point, our second row. Our third row is 2, 4. The x value is 2, so I move over to 2. My y value is 4, move up to 4. It's just occurred to me, you may have forgotten, I hope not, but if you did, the horizontal axis down at the bottom of your coordinate plane, that is always x. Thus, the y-axis is your vertical line on the far left. It is also known as f of x. So f of x and y are the same thing. Now that we have plotted all three of the points from our table, it's time to get out our ruler and connect them. So just leaving 3 points just sitting there quietly, no, that's not how it works. We need to know that these points are all connected and where they travel. So we also draw the line far beyond just where the 3 points stop. All right, and there you go. Example 2. We are going to complete the table where f of x is equal to x plus 3, and then we are going to graph the points from the table onto the given coordinate plane. In this particular example, I thought we would use the TI-Nspire to help us fill in the actual table. And in doing this, we have to remember just a couple of steps that were discussed in the introduction. Let's see. We start this by going to a graphing page. The easiest way to get there from the home screen is to just use this icon here at the bottom of the screen and clicking on that. The next step will be to type in the given equation that we found at the top of our table into our TI-Nspire calculator. Now, you may notice that your table says f of x, and your calculator might say f1 of x or f2 of x. Either way, it's fine. That's just calculator notation, keeping track of different functions that might have been put into this baby computer, because that's what it is. So we have x plus 3, and once we do that, hit enter, and this is what our graph is going to look like when we're done. At this point, if you push Control and the letter T, we now have the table of values given to us so that we can fill in our own table. Small caution. This table of values automatically goes 1, 2, 3, 4, 5, etc., etc. And the table on your specific problem may not go 1, 2, 3, 4, 5. Ours does not. So just be mindful as you are filling in points that you are looking in the accurate location. So our second row isn't asking for 2, it's asking for when x is 3. That has a corresponding 6. So just being mindful of the things that you are given versus what you are asked for as you are filling in your table. Now that we've filled in our table, we're ready to go plot our points. We remember that the horizontal axis is the x-axis, while the vertical axis is our y-axis, also known as our f of x. Remembering each point comes from each row. Our points are x and then y, where x moves left or right and y moves down or up. Let's plot our first row. X is 1, y is 4. So we go to the right one, up 4, make a point. Our second row is 3, 6. So the coordinate point 3, up to 6. Our third row is 4, 7. Go to the right 4, up to 7. Whoops, I made a little line. Our fourth row is 6, 9. To the right 6, up to 9. And finally, our fifth row is 7, 10. Go to the right 7, up to 10. Now that we have all of our coordinate points plotted, let's go ahead and get our ruler so that we can connect our points and make a nice line showing exactly how this set of points and all other points that weren't even listed on the table would behave. Remembering that as you draw your line, you definitely extend it before and beyond the points that you were given. A nice little thing to notice is that the graph that we were able to find on the calculator looks so much like the one that we actually drew. Now, granted, our graph is here at the origin using just the first quadrant of the coordinate plane. So this graph is being represented here in just this one quadrant of the calculator. So you can see that the line that was graphed on the calculator really looks just like the one that we drew, which is nice when things match up. So there you go. Example 3. We are going to complete the table given the function f of x equals 2x plus 1, and then graph its coordinate points here on the given coordinate plane. Let's go back to practicing filling in our tables by finding the values by hand. We see our function is 2x plus 1, and that is the framework that we are going to use for each row so that we can find the corresponding y values. So let's plug in the x values. So I have an x of 2, 3, and 4. Okay, let's go see what we make. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. Great, now we can plot our points. Remembering that each coordinate point goes x and then y, where x's move left if they're negative, right if they're positive, and y's move down if they are negative and up if they are positive. And our coordinate plane has the x-axis down at the bottom and the y-axis here on the left. Let's go plot our points. So each row is a coordinate point. Our first row is 2, 5. So we go to the right 2, up 5, make a point. Our second row is 3, 7. We go to the right 3, up to 7. There you go. And our third row is to the right 4 and up 9. So 4, 9 is all the way up here. Now that we have all 3 rows, all 3 points plotted, let's go ahead and connect our points. It is great to have a ruler just to help you see that things really do line up nice and clean. And yes, we remember to extend our line before and after where the points appear to stop, because this table could have gone on forever and ever. We could have had so many points listed down below it, or so many points listed up above it, an infinite number of points. Thus, we extend our line. And there you go. Example 4. We are going to complete the given table where f of x is equal to negative 3x plus 28, and then use its values to plot the points on the graph. I thought for this problem that we might again use the TI Nspire to help us fill in the points on the table. Let's remember how to use the TI Nspire to help you fill in the table values that you were given. Starting at the beginning on the home page, let's click on the icon for a graph. Now that we have an equation bar at the top of our screen, let's type in the equation that we have. It does not matter that this says f2 of x. Don't worry about that. Just start here with negative 3x plus 28. Once you hit enter, you will see just a little bit of it over here on the far right of your screen. That means that most of this line is happening somewhere else in the vast universe of the graph. And that's fine. It doesn't matter. Let's pull up the table by hitting Control T. And then be mindful as to what values are actually asked for on your table. Our table starts with an x value of 6. There it is. X value of 6 has a corresponding y value of 10. X value of 7 has a corresponding y value of 7. X value of 8 has a corresponding y value of 4. And our x value of 9 has a corresponding y value of 1. Let's use our table, remembering that each row is a coordinate point where x values, if they're negative, go left, and if they're positive, they go right. Y values that are negative go down and our positive go up. And on our coordinate plane, the x-axis is the horizontal bottom axis, and the y-axis is vertically given to us on the left of our graph. It is also f of x. Let's plot our points. Each row is a coordinate point. So 6, 10 will take us to the right 6 and up to 10. 7, 7 will take us to the right 7 and up to 7. 8, 4 will take us to the right 8 and then up 4. And finally, 9, 1 will move us to the right 9 and up 1. Now that we have all 4 of our coordinate points drawn, placed onto our coordinate plane, let's use our ruler to connect them. Extending above and below the line. And now we have the full distance of the line being displayed. And there you go. For our fifth and final example, we are going to again complete the table where f of x is equal to negative 2x plus 14, and then plot its coordinate points on the given coordinate plane. We can again use the TI Nspire to help us fill in the table. Starting at the home screen, let's click on the graphing icon. And now we can type in the equation that we were given into the equation bar at the top of the screen. Negative 2x plus 14. After hitting enter, we see that it is here in the first and fourth quadrants of the coordinate plane. This is what our final graph is going to look like, pretty much. But in the meantime, we need to fill in the table. Let's do that by pushing Control and then the letter T. We see that the table given to us starts with an x value of 5. Let's go down to it. We find that its corresponding y value is 4. When x is 6, the corresponding y value is 2. 7 has a corresponding y value of 0. 8 has a corresponding y value of negative 2. And finally, 10 has a corresponding y value of negative 6. Let's go plot our points. We know that all of our points are x and then y, with the x values that are negative moving left and the positive moving right, with the y values that are negative moving down and positive moving up. This graph is displaying all of the possible quadrants and values of x and y. Thus, the x-axis is here in the center, and the y-axis is also vertically in the center. Let's go plot our points. The first row, 5, 4, both values are positive. So x of 5 will move to the right. 4 is positive, it will move up, and we will plot that point. 6, 2. 6 is positive, we move to the right. 2 is positive, we move up. 7, 0. We move to the right 7, and then we don't move up or down at all. It's on the 0. 8, negative 2. Here's a negative value. We move to the right 8, but down 2. And finally, we have 10, negative 6. So we move to the right 10, and then we go down to negative 6. Now that all 5 of our rows, all 5 of our points have been plotted, let's get out our ruler and connect the points together. Always extending your points before and after where they start and stop, so that we can show that our line continues on in both directions infinitely. And we can see in this particular graph that we have created that it matches the one on the coordinate plane really nicely. So we see that The one on the calculator was here in the first and fourth quadrants, and the one that we drew is also in the first and fourth quadrants. We have the same slant occurring, so it's nice when things agree. That just helps us know that we've done things well and we've done them correctly. So there you go.